How does dry ice work?
Oh, it's just frozen carbon dioxide. That's all. Oh. So here's the difference. You have a block of frozen H2O and a block of frozen CO2. So there they are. It turns out the air pressure on Earth is high enough, at sea level, is high enough to allow the ice to melt and sustain a liquid state. Okay? The CO2 under air pressure, normal air pressure, it wants to melt, but it can't sustain a liquid, and it goes straight to gas. If we had much higher air pressure, you could have CO2 melt and have liquid CO2. So now watch what happens. So can I blow your mind again? This is really good stuff, okay? It's good like physical chemistry. So here you go. So watch what happens. So what happens if I reduce the air pressure? Okay? Well, the transition from ice to water is still the same. It's not affected, but the boiling point is affected. As you know, cooking times have to be adjusted on mountaintops because when you boil water, it's not 212 degrees. Depending on the height of the mountain, there's less air pressing down that's preventing it from boiling, okay? The boiling point is not some absolute fact about the water. It has to do with what the air pressure is sitting above it. If you have extremely high air pressure, water has to go to a much higher temperature before it boils. So the boiling point of water that's reported in all textbooks is at sea level, at 1 atmospheric pressure. That's how you get 212 degrees. If you start reducing the atmospheric pressure, it's 210 degrees, 205 degrees, 200 degrees, 190 degrees, 180 degrees.
180 degrees?
Oh, yes. And so that's not as hot as 212 degrees, so you got to cook the food longer. All cooking times are increased for this reason. So now watch. I'm not done with you.
Uh-oh.
Let's keep reducing the air pressure. Okay?
Theoretical or like possible on Earth?
No.
Like Himalayas?
Yeah, or take it up. You can ascend in some kind of copter or some kind of device, or air balloon or whatever. But I'm saying you can do this experiment in a laboratory. Okay? You keep reducing the air pressure. Boiling point keeps dropping. It's 170 degrees, 150, 120, 100 degrees Fahrenheit, 80 degrees Fahrenheit, 50 degrees Fahrenheit, 40 degrees Fahrenheit, 32 degrees Fahrenheit. Holy shit. What happens? The ice melts and becomes water. The water evaporates and becomes steam. And all of that's happening at 32 degrees. There is an atmospheric pressure for which water, ice, and steam coexist. And it's called the triple point of water. And all ingredients have a triple point.
Wow. What is the atmospheric pressure?
Mars is very close to the triple point of water. So you can have a simultaneous bath in certain regions of Mars. A simultaneous bath, because the air pressure is so low. It's like 1/100th Earth's air pressure. It's very, very low. So you have a place where a pot of water, ice cubes, and steam are coming out all at once. It's at the triple point. So here's the lesson here is we live life in our world at 1 atmospheric pressure, at 1 room temperature, atmospheric pressure, and we define what is normal based on that life experience, based on how our senses interact with that environment. But the actual universe is far freakier than what our senses are exposed, our 5 senses are exposed to on Earth.